What are you going to downvote? Don't downvote. All right, here we go, guys. This is lesson 2 of 2, analysis of graphs. That's what we did in notes 19. Do you guys remember? So hopefully you remember this much. If f prime is positive, what does that mean about f? F is what? Guys, come on. This is a theme for today. No, I don't know what that is. I don't know what that is. I don't know what this is. If f prime is positive, what's going on with f? No.
Oh, it's going up.
It's increasing. F is increasing. Guys, come on, guys. That was the theme from last time. If f prime is negative, f is decreasing. Don't be a robot. Make sure you know what's going on. F prime is slope of f. If the slope of f is positive, then you have to go up. If the slope of f is negative, then you have, instead of saying up, I should say increasing. Then f has to increase. If the slope of f is negative, then f has to decrease. Because the slope is negative. Left to right, it has to go down. Does that make sense, guys? Okay, so that's what we did last time. It says example 1, for each of the following functions, use the first derivative test, which is this, to find local extreme values. That means extrema. Identify any absolute extrema. Well, x cubed looks like this. So this is not going to have any absolute max or min, but it will, if I have a derivative that changes signs, I will have an extrema. If my derivative, if f prime changes from positive to negative, what does that mean about f? I have a what? A max. If f prime goes from negative to positive, I have a what? Min, that's all. So here we go. I'm glad you guys remembered. Guys, so here we go. F prime of x. 3x squared minus 12. I'm going to find my critical numbers. So I'm going to factor out a 3, and I get x squared minus 4. Equal that to 0. And you could either do the difference of squares or just look at it. X squared minus 4 equals 0. So that means x equals plus minus 2. Does that make sense to you guys? Okay. So that's just the algebra part. Here's my railroad tracks. And I guess what I should be calling it is a sign chart. But I'm still going to call it railroad tracks. And all I care about is positive, negative, negative, positive. All I care about is my sign of that derivative. Are we still okay? Okay, if I put a number smaller than negative 2, like negative 10, negative 10 squared is 100. 100 minus 4 is a positive number, so put a plus symbol to the left of negative 2. If I insert a number between negative 2 and 2, like 0, 0 squared is 0. 0 minus 4 is a negative number, so I put a negative. And if I put a number like 10, 10 squared is 100. 100 minus 4, 96, so positive. Do you guys see that? Okay, so at negative 2, what does f have? A max or a min? A max. Yeah, just do your little thing. Left to right, I'm increasing, and then I start decreasing. I'm doing it with respect to you instead of me. With respect to me, it would have been like this. See? You always go left to right. So here we go. So I'm going to say f. So you got to say what is f has a max at x equals negative 2 since f prime changes from positive to negative at x equals negative 2. And I know it sounds funny to say it again, but just say it again. What about at 2? My derivative is going from negative to positive. What is that? A min. What has a min? F. F has a min at x equals 2 since f prime changes from negative to positive. There it is, at x equals 2. Say it again. I know it sounds funny, but just say it again. And maybe this is not a really good candidate to introduce absolute min and absolute max. I guess you know what, before we do that, do you guys want to see how that question looks or how that graph looks? Really fast? Should we do it in a calculator? Should I do it in Desmos? You guys do it in your calculator and I'll do it in Desmos. See which one's faster. minus 12x minus 5. All right, I got it to look like this. I had to fix my little scale a little bit. It said that I had a max at x equals -2, and sure enough, there's a max there. See? It says that I have a min at x equals 2, and sure enough, there's a min there. If you wanted to see your derivative, this does the derivatives, f prime of x. That blue curve is my derivative. And check it out. It is positive to the left of -2. It is negative between -2 and 2. Do you guys see that? So do we know the difference between positive and negative? Like when we say positive? So the blue graph is my derivative graph. Notice it is positive. It's above the x-axis to the left of -2. So sure, look at the red graph. Sure enough, it's increasing until I hit -2. Right at -2, it's a 0, so I have a horizontal tangent there. You guys see that? Between -2 and 2, notice that my blue curve here is below the x-axis, which is the blue curve is the derivative. And notice the red curve is decreasing between -2 and 2. Well, I need to zoom out because you can't see it, but do you guys see what I'm talking about? Isn't that cool? Yes, it's so cool. There it is, see? And I'm decreasing until this point. And then after 2, I'm increasing forever. Cool, right? Okay. Let's go to the next one, guys. It says g of x equals x squared minus 3 e to the x. Okay. When I say this is a bad problem to determine if I have absolute min, it's because we haven't practiced enough. But just real quick, end behavior of x squared looks like this, right? And then end behavior of e to the x, if I have an x-axis here, it looks like this. Well, that's how e to the x looks like. So I know because this increases forever and these two ends increase forever, when they go up forever, I know that I'm not going to have an absolute max. I might have an absolute min because I can see like positive infinity times 0. In this case, I think it is going to be 0. Not always. It's indeterminate form. But that's for another lesson. Maybe this is not the best question to say identify any absolute extrema. But if I do have something that goes from negative to positive, it would be a candidate for absolute min. This one would not have a candidate for absolute max. Does that make sense? All right, here we go. Let's find the critical numbers to find my candidates for maxes and mins. If you don't want to worry about absolute, then don't worry about it. For this one, don't worry. All right, here we go. I'm just going to take a derivative. First times root of the second plus second root of the first. Equal that to 0. We're done with calculus. We're just doing algebra. I look at this, and like, let me factor out an e to the x. E to the x, parenthesis, x squared, and then I see a 2x here, so I'm going to write plus 2x minus 3. Is this factorable? Yes, it is. X, 1 and 3. And the bigger number has to be positive, so bam, and then bam. E to the x will never be 0. E to the x will never equal 0. I mean, the limit, if x approaches negative infinity, it will be, but it will not be 0 ever. What's up, miss? Just put it in order. I didn't have to do that. But it's a lot easier to factor out this expression than if I were to have this like this. I'm like, I gotta find factors. Like, you gotta write it in terms of ax squared plus bx plus c equals 0. And then if you write it like that, you can factor it out pretty quickly. All right, here are my two values where this is 0. X equals 1, x equals -3. I do a railroad track. I call this f prime. This is actually a sign chart, but I call it a railroad track. 3 and 1. Oh yeah, it is G prime. Thank you, miss. I think we still would have gotten the correct conclusion, but yeah, it's G prime, not F. Yeah, no, we have to keep the correct symbols. All right, -10. -10 minus 1 is a negative. -10 plus 3 is still a negative. Negative times a negative? positive. E to the x is always above 0, by the way. Maybe I should write that. E to the x is always greater than 0. It's always above the x-axis. Between negative 3 and 1, like what's a good number? 0. 0 is the best number. 0 minus 1, negative 1. 0 plus 3, positive 3. Negative times a positive? Negative. And a number bigger than 1, like 2 or 3. 2 minus 1, positive. 2 plus 3, positive. Positive times a positive? Positive. We read a graph left to right. What do I have at negative 3 if it's going from positive to negative? Max. What about at 1 because I'm going from negative to positive? Min. So I'm going to write, let's write right here. Let me see. Can I fit it in there? I'll put it in blue. G has a max at x equals negative 3 since G prime changes from positive to negative at x equals negative 3. And then what do I have at 1 again? G has a min at x equals 1. And I really shouldn't abbreviate. I should be writing minimum, but that's fine. Minimum at x equals 1 since G prime changes from negative to positive at x equals 1. And there it is. By the way, x equals 1 is also an absolute min. You wouldn't know that because this is a bad example. So next year I'll probably change it. But let's look at it. Let's see how it looks on a calculator. Let's see who's faster. I already have Desmos here, so it's really not fair. X squared minus 3, right? What did I put? X squared minus 3 or something? Times e to the x. So there it is. I don't know if you can tell, but this green curve is actually above the x-axis forever. It just looks like it blends into the x-axis, but it's not. Chav, how do you know? Look, G of negative 10. Look at that number. It's positive. Chav, what about G of negative 1,000? It's defined. It's just, oh, I didn't put negative. It's defined. It just says 0, but it's not. Look at G of negative 100. There is 39 zeros in front of that 3. It's practically 0, but it's not. Cool, right? And then look, it definitely is a minimum. Bam! There's definitely a minimum at 1. And it's an absolute minimum, by the way. But yeah, this one was a bad example to showcase that. So I'll change out that example later on. All right. Do you guys remember concave up, concave down, an inflection point? Draw a sinusoid. What is this? Concave down. It's a safe space, but this concave down. This one is concave up. And right smack in the middle between concave down and concave up, bam, what do we call that? Inflection point. So an inflection point is just where concavity changes. Parenthesis, where concavity changes. Nothing crazy. How do we feel? Are we okay? All right, here we go, guys. Let's see if we can figure this out. Let's observe the behavior of f prime when f is concave up. So I'm going to draw f. This is just f. I'm drawing something strictly concave up. And I'm calling this f. I'm going to pick some random points. And I'm going to, so here's my tangent line. And I'm going to call that f prime. And I'm going to say that's like negative 8. I'm going to say that f prime there is like negative 4. What is that one? 0? Yeah, it's a horizontal tangent. And I'm just going to make it symmetrical. I'm going to say that's like f prime equal to 4. I'm not putting any numbers because I don't have a scale here. And I'm going to say this is like f prime equal to 8. Before I continue, does everyone agree this is a strictly concave up graph for f? Okay. I want you guys to observe. Look what's happening. Oh, I just got the chance. Look what's happening to f prime. -8, -4, 0, 4, 8. I'm just talking about f prime. What observation do you notice about f prime? F prime is what? -8, -4, 0, 4, 8. No, proportional. Tell me what's happening to that number.
It's increasing.
It's what?
Increase.
Okay, so what's increasing? The slope of f. So don't call it, well, I guess you can call it slope of f. You're fine. But what's a better name? F prime. F prime, no, be careful. Don't say f prime prime. F prime prime is positive. Well, I don't want to give the answer. Dang, I might have given it away. F prime is, what did you guys tell me is happening with f prime? F prime is increasing. Guys, the only way f can be concave up is if f prime is increasing. That's the only way. This is a strictly concave up graph. You agree? The only reason that this is concave up is because f prime is increasing. You have to. Sorry, your slopes must be increasing in order for you to have concave up. Think about that. Like, see, the increasing slopes is what created this figure of concavity. -8, -4, 0, 4, 8. Because I have my slopes increasing, that's what creates this shape on my F graph. Must. Is this making sense in your brain? Okay, so write that down. The only reason why we have that shape concave up is because f prime is increasing. The slopes of your f are increasing. So that's what creates concave up.
So it doesn't matter which direction at first is going.
Well, you got to read it left to right, but as long as left to right, f prime is increasing or the slopes of f are increasing, the slope of f. Be careful, don't say the slope of f prime, because that's f prime prime. Okay, you guys ready? What do you think, Morales? You think we're ready?
When you say f prime prime,
Oh, we're not there yet.
okay.
But it's f prime prime is the derivative of f prime.
Okay.
I guess you can already start making a conjecture, but I don't know if Gonzaga heard me say the answer. I hope you don't remember the answer, Gonzaga, and you can just come up with it with. I hope just do critical thinking, and like you know what I mean. I'm drawing a strictly concave down graph. I'm going to call this f. You already know what I'm doing. Boom. F prime is 8. F prime is 4. I don't know. I just like those numbers a lot. F prime is 0. F prime is -4. F prime is -8.
I have a question. How can the numbers be on the right, or is it just
What?
because there's negative numbers on the right?
Yeah, that's fine. I'm just reading this graph left to right. Those slopes are negative.
Okay. Oh, okay.
I'm just talking about my slopes.
Okay.
See, there's I'm going down. See how at that moment this graph is decreasing f?
Yeah.
So that's a negative slope.
I'm just getting confused with the direction of the line.
I'm just going left to right. You always read a graph left to right. Left to right, this is strictly concave down. Do you guys agree? Look what's going on. Add a slope of 8. Add a slope of 4. Add a slope of 0. -4. -8. What's happening to f prime? It's decreasing. Because f prime is decreasing, this is why f is concave down. F prime is decreasing. Does that make sense, guys? That's what creates concave down. The fact that f prime is decreasing, that's what creates this shape. Cool or not cool? Are you sure? Do we got it down for sure? All right, Gonzaga, here we go. What conjecture can we make about f prime prime? Pretend we didn't hear that answer. Maybe you did. I don't know. Don't be a robot. Look what you told me up here. This is well. I guess you didn't tell me that, but you told me earlier today from last week, that if f prime was positive, we said that f is increasing. If f prime was negative, we said that f was decreasing. Using the same conjecture, f double prime is only one derivative away from f prime. What conjecture can we make about f prime prime? If f is concave up, that means f prime is increasing. What does that mean about f prime prime? No. Do you say decreasing?
No, I said nothing.
Oh.
I'm just kidding. It's because I thought like multiplying. No, I don't.
If f prime was positive, you told me f was increasing. So if I tell you f prime is increasing, what is f prime prime? No, not decreasing.
Increase.
No.
What?
Guys, think about it. It's not. We don't have to go super hard. I guess you can go backwards also. If f is increasing, f prime is positive. If f prime is positive, f is increasing. Or if f is increasing, that means f prime is positive. So what does it mean about f prime prime if f prime is increasing? What does it mean? What does it mean? We're gonna figure this out, guys. The relationship between f prime prime and f prime is only one derivative away. Look, guys, you guys already told me. Look, you guys told me this definitively. F prime is positive, f is increasing. So if f is increasing, f prime is positive. If f is decreasing, f prime is negative. So think about it, guys. We don't have to use a lot of muscle. If f prime is increasing, what is happening to f prime prime? Question mark. What? Say it. Oh, okay. Maybe we're getting somewhere. What's f prime prime? Yeah, that's it.
I said like 5 minutes ago.
Did you really? I didn't hear you, miss. Did you say it softly?
That's why we're so confused because Sophia already said it, so we were like, yeah, that's the answer.
F prime prime is positive. So f prime prime being positive tells us two things. What does it tell us? It tells us that f prime is what? Increasing. Sorry, miss, I didn't hear you. At least maybe you did say it, but you said it so softly that I didn't hear it. If f prime is increasing, what does that tell us about f? No, it's not positive. Concave up. If f prime prime is positive, we do not know anything about f other than the concavity. If you know f prime, if you have a graph of f prime, then you can tell me if it's above the x-axis, then f is increasing. If it's below the x-axis, f is decreasing. But if you just have f prime prime, then all you can tell me is that f prime is increasing or decreasing, or f is concave up or concave down. That's it. Cool or not cool? All right. What does it tell you about f prime prime if it's negative? F prime is decreasing. F is concave down.
And why is f prime prime increasing?
Oh, we don't know if f prime prime is increasing. We just increasing or decreasing. We don't know about f prime prime. That all we know is if f prime is positive or negative. We're not going to go into the fourth derivative. If the fourth derivative is positive, then we know f prime, or third derivative. If the third derivative is positive, then f prime prime is increasing. But we're not going to go that far. They're all connected, guys.
So they're all the same.
No, but they're connected. Don't say they're all the same. If f prime is increasing, okay, let's just give me a scenario. Do you want f prime to increase or do you want f prime to be positive? You can't do both. Not right now. We're not there yet. Okay, if f prime is increasing, all I know is that f is concave up. That's it. If f prime is positive, then f is increasing. If f prime prime is positive, then I know f is concave up, and I know that f prime is increasing.
So we're breaking it into parts.
Finally, we want to get to be able to figure out what's going on with f. Are we still okay, guys? Okay, check it out. We got two little examples. It says, use a concavity test, sometimes called second derivative test. So let me go ahead and write that. Sometimes called second derivative test. So you'll hear both of those names interchangeably. To determine the concavity of the given function on the given interval. Y equals x squared on 3 to 10. Okay, you guys ready? Well, it says to use a second derivative test or concavity test. Y prime, 2x. Y prime prime, 2. Since y prime prime is always positive, comma, y equals x squared is always concave up. We know that. Y equals x squared looks like this. Yay or nay? Perfect. 3 plus sine x. Look, what's up?
So we don't use the point at all?
What point? There's no point. Oh, you can say that. It's always concave up. Well, that's fine. Maybe I judge. I should have said it's concave up on 3 to 10. But look, it's always concave up. It doesn't matter what my domain is. If I would have had an x, then I would have it's only concave up between 0 and infinity, or it's concave up between 3 and 10. But I don't, you know what I mean? I'm just 2 regardless of the interval. But sometimes that interval does come into play. But in this case, it didn't. All right. Next one. Y equals 3 plus sine x on 0 to 2 pi. This one's going to come into play. All right. Y prime equals, what's the derivative of sine x? Cosine x. Y prime prime, what's the derivative of cosine x? I'm going to do parentheses. Because with concavity, use parentheses. With increasing, decreasing, use brackets. I'm going to call this y prime prime, 0 to pi. And where is this equal to 0? At pi. A little bit of pre-cal, not a lot.
Wait, why do you use parentheses?
Because you're concave up and concave down, and you never include the point of inflection. Because at the point of inflection, you're not concave up or concave down.
Okay.
But for increasing and decreasing, you are going to use a bracket. All right, because you increase and decrease on a closed interval. All right, here we go. Ready? Any number between 0 and pi for sine on the unit circle would have been positive between 0 and pi, but I have a negative in front of this. So negative times a positive is a negative. And any number between pi and 2 pi, that's quadrant 3 and 4 for sine. And quadrant 3 and 4 in the unit circle, sine would have been negative, but I have a negative in the front. Negative times a negative, positive. All right, I'm gonna write a statement. Y equals 3 plus sine x is concave down on the interval parentheses 0 comma pi close parenthesis, since y prime prime is negative on this interval. This is how you say negative, by the way. Y prime prime less than 0. I'm going to change colors to do the other one. Y equals 3 plus sine x is concave up on the interval parenthesis pi comma 2 pi close it, since y prime prime is greater than 0 on this specific interval. Oh, I didn't say specific interval on the last one. That's fine. But my habit is usually to say the word specific. Let's draw it really quick. See if we can draw it. 3 plus sine x. Not perfect, but that's fine. Here's 0. Here's 2 pi. And sure enough, look at that. That's pi. Yep, between 0 and pi, I'm concave down. And between pi and 2 pi, I'm concave up. It worked. Good job. Cool, right? How do we feel, guys? All right. Find all points of inflection on the graph of y equals e to the negative x squared. And only because we just had pre-cal class not that long ago, that 0.707 is square root of 2 over 2. So that means right there and right there, because they're both symmetric. I want you to notice, so that value here, that one is x negative square root of 2 over 2. And this value here, that's x equals square root of 2 over 2. So those are points of inflection. So let's see if we can do our algebra to get those points of inflection. Are we cool, guys? Does everyone know what we're about to do? We're going to take the derivative how many times? 2 times. And I'm going to look for a change in signs. So here we go. Y prime equals, what's the derivative of e to the negative x squared? E to the negative x squared times negative 2x. I'm going to leave it like that. I'm going to do product rule. First, times root of the second, plus second, root of the first. E negative x squared times negative 2x. Are we still okay? I'm going to group them. Consider this like a term and consider this like a term. So here's what I'm seeing. I can see that I can factor out an e to the negative x squared, giant parenthesis. So let's see what I'm going to have. Negative 2 plus 4x squared. Ooh, I could have factored out a 2 as well. Too bad. I didn't do that. That's fine. I'm going to equal this to 0. Job, why do you equal it to 0? Because that will be a candidate for a sign change. Just because you equal it to 0 doesn't mean it's guaranteed. Well, in this case it is, but just make sure you understand that. Don't be a robot. You got to look for a sign change. That's why I always do the railroad track. All right, here we go. This will never be 0. E to the negative x squared will never equal 0. But this will, and maybe if you think about it, maybe you could have factored out the 2. I didn't factor it out, so I'm just going to leave it. All right, here we go. Negative 2 plus 4x squared equals 0. Move the 2. 4x squared equals 2. Divide by 4. X squared equals 2 over 4 is the same thing as... Not everyone at the same time. 1/2, right? 2 divided by 4 is a half. Yes. Divide by 4, divide by 4. Come on, guys. Sorry, I am going kind of fast because, I need to make sure that I take over for Abilene a little bit. All right, here we go. Maybe I can go into like 5 minutes. Well, we'll see. Square root. X equals the square root of 1 over the square root of 2. So that is 1 over the square root of 2. Rationalize. Square root of 2 over 2 plus minus. If you do the railroad tracks, they don't give me a domain, so I'm just going to write negative square root of 2 over 2, square root of 2 over 2. Y prime prime. If I pick a number to the left of negative square root of 2 over 2, like negative 1, and I plug it in here into this one that I'm underlining, negative 1 squared is 1. 1 times 4 is 4. Negative 2 plus 4 is a positive number, so plus. You don't care about the e to the negative x squared. It's always going to be positive. If I pick a number like 0, negative 2 plus 0 is negative 2, so negative. If I pick a number like 1, negative 2 plus 4, positive. Concave up on the interval, negative infinity to negative square root of 2 over 2, and square root of 2 over 2, comma, infinity, period. Since, you know what, let me put a since y prime prime is positive on these intervals. Oh, they didn't want that. They just wanted point of inflection. Dang it. That's fine. Point of inflection, point of inflection. Points of inflection occur at x equals plus minus square root of 2 over 2. Since y prime prime has, let me put a line through it, has sign changes on these values. Has sign changes on these specific x values. Okay, let me read it to you guys, the answer. Points of inflection occur at x equals positive or negative square root of 2 over 2, since y prime prime has sign changes on these specific x values. Perfect. What's up, Johnson? Okay, I thought you were going to ask me a question. We're going to stop. Let me do one more, example 4. And Miss Abelie, don't hate me, miss. Okay, I'm going to send her this video. The graph of the derivative of a function f on the interval negative 4 to 4 is shown on the right. Answer the following questions about f, justifying each answer with information obtained from the graph of f prime. No, don't worry. We'll finish pretty quick, hopefully. Don't get mad at me, Abelie. Oh, yeah, those we're going to do tomorrow. We didn't do them all either for first period. All right, before we continue, do we understand what graph this is? What graph is this? F prime. Label it, F prime. All right, it says, on what intervals is F increasing? Well, F is going to increase as long as F prime is what? No. No. Positive. As long as, guys, F prime is the slopes of F. As long as F prime is positive, F is going to increase. Where is it positive? No. Negative 4 to 1. That's why I'm above the x-axis, where it's positive. So here it is. Are we okay, guys, right now? Okay. Make sure to state F. So you're going to write F is increasing on the interval. Remember, for increasing, you use brackets. On the interval, bracket, negative 4, comma, all the way to 1, close bracket, since F prime, and I'm going to write it like this so I don't have to write two separate intervals, greater than equal to 0 on this specific interval. If I would have just said F prime greater than 0, I would have to cut it into two pieces. I didn't want that. It's always positive. There it is. It's always greater than or equal to 0 on this specific interval, so that's why F is increasing. Does that make sense? Okay. What intervals is the graph of F concave up? Now I want to know where F is concave up. No, go ahead. This is a safe space.
Negative 4 to negative 1.
No.
What? Oh, negative 4 to 0.
No.
What?
Look at your notes. Look where I was concave up. Look what it says right here.
Oh.
Let me use my laser. Look what it says right here. No. Look what it says right here. What is increasing? F prime. So when F prime is increasing, I'm concave up. What graph am I looking at? F prime. So where is this graph, the F prime graph, increasing? No. Three to 4. That's one. 3 to 4. There's another one. Negative 2 to 0. It's not quite perfect to 0, but let's assume it is. So there it is. That's where F prime is increasing. So I'm going to write F is concave up on the interval. Now for concavity, use parentheses. On the interval, parentheses, negative 2, comma to 0. And comma 3, comma 2, 4, since F prime is increasing on these specific intervals. Did that make sense? Morales, did that make sense? You're not just telling me that just to tell me that. Okay. Are we okay, guys? All right. Letter C. Oh, go ahead. Yes. Tell us what. Wow, we didn't even read the question. Which x coordinates does f have a local extrema? So that means max or mins. Don't forget endpoints. I'm going to put forget endpoints. Forget endpoints. Or exclude endpoints. Exclude endpoints. For now. All right. Y at 1, fam? Perfect. Which means it's a what? Max on f. So I'm going to write f has a max at x equals 1 since f prime changes from positive to negative at x equals 1. F has a max at x equals 1 since f prime changes from positive to negative at x equals 1. Perfect. There it is. We just got 2 more letters. Zamora Johnson, tell me.
0, -2.
What? Oh, okay. I thought you were talking about Z. What are the x coordinates of all inflection points on the graph of f? All right, where are my inflection points?
0, -2.
Let's see, 0, yes. -2, yes. And 3, yes. I'm going to put them in order. You always want to go left to right, but that's fine. I'm going to write f has points of inflection at x equals -2, 0, 3, since f prime goes from what to what? No, you're right. You got it right. It goes from what to what? And vice versa. Yep. I'm just going to say the word vice versa because I just want to write short sentences. F has points of inflection at x equals -2, 0, 3, since f prime goes from decreasing. You always want to state the first one. To increasing. And vice versa at those specific x values.
Why didn't you start with decreasing first?
Because that's what we started. It started the f prime started decreasing first.
Okay.
You want to start with the first one first. So decreasing, you always read it grab left to right. Decreasing to increasing and vice versa. You could have also said f prime prime, but do I have the f prime prime graph? No, but you do kind of. Like f prime prime right here is negative. So you could have said, because f prime prime changes signs here, f prime prime is positive, f prime prime is negative, and then here f prime prime is positive. But since you don't have the f prime prime graph, you want to reference the graph that you're given. You know what I mean? Okay. All right. Last one. Sketch a possible graph of f on the interval -4 to 4. They don't tell us where I start. Guys, to make life easier, you only have 4 graphs. There's only 4 graphs. So concave up. You either have an increasing concave up graph or decreasing concave up graph. Let's see. Decreasing. There it is. See? Increasing concave up, decreasing concave up. Do you guys see that? Concave down. So I'm just going to put the word down. So you either have a decreasing concave down graph, decreasing concave down, or an increasing concave down, what did I say? Oh, yeah, concave down. Decreasing concave down graph. So this way. Do you guys see that? Okay. Those are the only 4 we have. Concave down, concave up, increasing, decreasing, increasing, decreasing, or vice versa. All right, so here we go. You don't have a y-axis. I'm just going to draw an x-axis. That's all I'm going to do. X-axis here. Let me do it in black. You know what? I'm going to color code this because I think it's best color coded. So I'm going to erase all this, and I'm going to color code it based off of the parts. We're going to cut it in pieces. So my first part, I'm going to do it in purple. So I'm going to draw this in purple right here. This is my first part. We're talking about F. So I'm going to write F, neutral color, F. All right. Here we go. What color did I choose? I already forgot. Purple. All right. Tell me, in that purple scene, tell me about F. Is F increasing or decreasing? F. No. It's increasing because it's above the x-axis.
Yes.
Yes or no? Okay, tell me about my concavity. Concave up or concave down? Concave up or concave down?
Up.
This is that prime, guys. Concave up or concave down? It's not concave up, guys. Okay, relax, relax. Guys, look, you just told me. Strictly concave up, F prime is increasing. Strictly concave down, F prime is decreasing. You have the F prime graph. Let's do it again. So here we go. Okay, let's do it again. Just this part. You already told me I'm above the x-axis, F is increasing. Perfect. This is F prime. F prime is decreasing, so that means F is concave. Perfect. So draw me an increasing concave down graph from -4 to -2 and a -2 a horizontal tangent. So like this. What did I say? Increasing concave down. Increasing concave down. And then right at -2 horizontal tangent. There it is. So that part is that part. Increasing concave down. Are we still okay? All right, I'm going to change the color to red. Tell me what's happening here. Is F prime, let's just do it slow. Is F increasing or decreasing? F. Increasing, F prime is above the x-axis. And what's the concavity? No, look, what's happening to F prime? F prime is increasing, so that means F is concave up. So, increasing concave up. Increasing concave up. Increasing concave up. For just a little bit, increasing concave up. There it is. I'm going to call that 0. Next color, blue. Just for this part right here, because I'm going to do it in little pieces. Okay, tell me what's happening to F. Increasing. What's the concavity? Concave down, because F prime is decreasing. So, increasing concave down. And right at 1 horizontal tangent. So, increasing concave down. Here it is. Increasing concave down. Boom. Right at 1 horizontal tangent. There's a 1 right there. All right. What color have I not used? Burnt orange. Okay. Tell me what's happening in this burnt orange from 1 to 3. F is decreasing. And what's my concavity? Concave. You're right. Concave down because F prime is decreasing. So, decreasing concave down. Decreasing concave down. Decreasing concave down. There it is. Like this. See? Decreasing concave down. And then I'm going to stop drawing right there. Let me pick. I haven't used black. Let me use black. No. Not black. I haven't used green. Let me use green. All right. Here we go. From 3 to 4. I'm still decreasing because F prime is negative, but it's concave up, and right at 4 it touches the x-axis, so that means a horizontal tangent at 4. So I am decreasing concave up. Decreasing concave up. So here it is. Decreasing concave up. And then bam, horizontal tangent. 4. And the burnt orange, this was right here, was what was that, a 3? Yeah. And it kind of looks like an elephant. Do you guys see that? Okay, the only way to get really good at this is with lots of practice. I'm going to go ahead and check out now, guys, because Abeli's probably waiting for me. Please take care of the delta. If you're having trouble with the delta, stop, because it can be very easily annoying. You know what I mean? Because there's a lot. If your head's starting to hurt and it gets annoying, stop and ask me. Notice that the due date is not till tomorrow. That's for a reason. That's by design. If you're getting them wrong, just stop doing it. Cool or not cool? All right, we're done, guys.